In our previous lecture, we discussed about motion of projectile. Now, we'll discuss another concept of projectile, but this time this concept is horizontal projectile. So, what is horizontal projectile? Suppose I'm standing on the rooftop of a building. Here, I throw a ball along with horizontal axis. Then, how will be the path of this uh, projectile body? So the projectile motions of this body will be like this. When we throw something along with horizontal axis, then this is known as motion of horizontal projectile. So let us derive some equations of this horizontal projectile. Suppose this is the x-axis and this is the y-axis. This is our x-axis and this is our y-axis. Suppose I throw a body along with this x-axis, then how will be the path of this body? The path of this body will be like this. Suppose I throw the body at the velocity of v0. Here, as I throw the ball along with x-axis, so the theta naught along with x-axis is 0 degree. We know for this v0 component, for this v0 vector along with x-axis, the component will be vx0. We know in our previous lecture, we know for vx0 we can say that vx0 equals to v0 cos theta naught, v0 cos theta naught. As theta naught equals to 0 degree, so we can write this thing as v0 cos 0, and we know the value of cos 0 is 1, so we can write this vx0 equals to v0. So we can write vx0 equals to v0. And what about the component of y-axis? So it will be vy0. Vy0 equals to v0 sine of theta naught. And as theta naught equals to 0, then it will be v0 sine 0 degree, which is equals to 0. So along y-axis, the vy0 equals to 0. So we derive some formula about our horizontal projection. So let us now derive another equation. The equation is after t second, what will be the velocity? What will be the velocity? What will be the velocity? So let us consider that after t second, the body is coming at that point. So here two components are exist along, one is along with x-axis and one is along with y-axis, and this is our resultant vector v. And along with x-axis, the component of this v is vx and the component of this y is vy. So we can write this for vx. From our previous lecture, we know that for vx we can write vx0 plus 80. And we know along x-axis acceleration is 0. Acceleration a equals to 0 along x-axis. So we can write this, and we know vx0 equals to v0. So we can write v0. So we can write v0. And along y-axis, it will be v0 plus gt. Why vy0 plus gt? Why this is plus gt? In the previous case, we throw the ball against with gravity g. Now, as in that case, we throw the ball along with gravity g. So, in that case, the acceleration equals to plus g. Acceleration equals to plus of g. So for that, we write this vy0 plus gt, and we know along y-axis vy0 equals to 0. So we can write this as V as gt. You can write this as gt. So this is our formula for x-axis, and this is our formula for y-axis. So if I want to find out the resultant vector v with the help of this component, we can write vx square plus vy square, vx square plus vy square. So we find out another two equations. Now what will be the angle after t second? It makes an angle of theta along x-axis, this d. So what will be the angle? The angle will be tan theta equals to, if I draw an triangle of this, then from that we can write this as this is vy, that will be also vy, that will be also vy. From that we can write that for tan theta, as this is vx and this is vy, we can write this as vy by vx. So we can also find the angle after t second. Now let us derive the equation of this projectile, horizontal projectile. So what will be the equation of this horizontal projectile? We know along x-axis the distance is covered is suppose x after t second. After t second, along x-axis it cover x distance, like this is the x distance, and this is the this is the x distance, and this is the y distance. So along x-axis we can write x equals to v x naught t plus 80, and we know along x-axis a equals to 0, so we can remove this thing. So it will be vx naught t, vx naught into t, and we know the value of vx naught equals to v naught t. From that we can write t equals to x by v naught, and along y-axis the distance after t second along y-axis will be we know it is v y naught t plus half of gt square, as a equals to plus of g, acceleration equals to plus of g, and we know v y naught equals to 0, so it will be, we can remove this thing, then we will get half of g t square, half of g t square. If I replace this t of with x by v naught, I can find out half of g into x by v naught whole square. From that we can write x square equals to 2 v naught square by g into 1. So if I write this thing like x square equals to, as I replace this 2 v naught square by g with 4a, then it will be look like this 4ay, and this equation is known as parabolic equation. So this path is also a, as it is a parabolic equation, so this path is also known as parabola. So this path is also known as parabola. So the projectile path is parabolic path. Now we'll solve some problem of this projectile motion. Now first question is, a body is projected with a velocity of 10 meter per second at an angle of 30° with the horizontal. Our first question is, how much time will it take to reach the maximum height, and what is the velocity of the body after 0.3 seconds? Here another extra information is given, that here our value of g equals to 10 meter per second square. If the value of g isn't determined, isn't given, then we will take the value, the standard value of g is 9.8 meter per second, as in our question it is mentioned that g equals to 10 meter per second square. So we will solve this equation with the value of g equals to 10 meter per second square. So how we will solve this equation? First of all, for our first question, here I have to find out how much time will it take to reach the maximum height. That means if this is the path of the body and says that the v naught, the initial velocity is 10 meter per second and the angle is the theta naught equals to 30 degree. We have given these two values and I have to find out how much time will it take to reach the maximum height. This is the maximum height. So how much time will it take to go from there to there. So if I want to solve this thing, we know along x-axis the vx naught equals to v naught cos theta naught, and along y-axis the component along y-axis of v naught equals to v1 naught equals to v naught sin theta naught, v naught sin theta naught. Now we know suppose the body is moving from that point to that point, and after that point, when it comes to point C, if I mention this as point C, when it comes to point C, the y component of this when it comes to point C, the y component of this body will be Vy. We know Vy equals to Vy naught minus of Gt. Vy naught minus of Gt. When the body is coming at the maximum height, then the y component of the velocity of y component will be 0. So at that point, the velocity of y component will be 0. As it is 0, then it will stop there, and after that it is coming downwards after t seconds. So we know as Vy will be 0 at maximum height. So we can write Vy as 0, and for Vy naught we can write V naught sin theta, and here will be minus of Gt. So if I solve this equation, I can write t equals to V naught sin theta by G. V naught sin theta by G. So if I put the value like V naught equals to 10 sin theta sin 30 degree, and mention that G equals to 10 meter per second square. So I will find out the value of t equals to 0.5 second. 0.5 second. So how much will it take to reach the maximum? So the time will be taken at the time will be taken is 0.5 second to reach the maximum height. So we solve the first question, then coming to the second question. The second question is, what is the velocity of the body after 0.3 second? So after 0.3 second, I have to find when t equals to 0.3 second, what will be the velocity of that body. So first of all, after 0.3 second, what will be the velocity along x-axis? It will be v naught. It will be v naught cos theta naught plus not plus it. We know along x-axis the acceleration is 0, so there will be no term. And if I put the value of v naught equals to like v naught is 10 and cos theta equals to 30 degree, so the value will be 8.66 meter per second. 8.66 meter per second. And if I find out value along velocity along y-axis, then it will be v naught sin theta naught minus gt. So v naught equals to 10 sin 30, g equals to 10, and t time equals to 0.3 second. So t will be 0.3 second. So the value will be, if I put this value, it will be 5 minus 3, which is equals to 2 meter per second, which will be equals to 2 meter per second. As I know the velocity along x-axis and velocity along y-axis, then I can find out the resultant velocity v equals to root over vx square plus vy square. So it will be equals to 8.66 square plus 2 square, which is equals to 8.9 meter per second approximately. So after 3 seconds, the velocity of the body will be 8.9 meter per second. Now another question, The second question is, a ball is projected an angle of 30 degree with the horizontal with a velocity of 20 meter per second from the top of a tower height of 40 meter. When and what distance from the bottom of the tower will the ball touch the ground, and also calculate the velocity of the ball when it reaches the ground. And here also our value of g is 10 meter per second square. So first of all I draw the whole concept. Suppose this is our rooftop. So this is our rooftop or top of the tower. A ball is projected at an angle of 30 degree. At an angle of 30 degree. So the position will be like this, and this is our ground. So first question is, when and what distance from the bottom of the tower will the ball touch the. So suppose after t second, suppose after t second the ball after t second the ball touch the ground, and the distance is, suppose the distance is give me some time, the distance is suppose x meter from the bottom of the tower. We know along x-axis the component of v naught, here v naught equals to 20 meter per second. The component of v naught will be v naught cos theta naught, which will be equals to 20 into cos 30 degree equals to it will be equals to 17.32 meter per second, and along y-axis v1 naught will be v naught sin theta naught, which will be equals to 20 into cos not cos sin 30 degree, which is equals to 10 meter per second. 10 meter per second. Now coming to the first question. Our first question is, when and what distance from the bottom of the tower will be the ball touch the ground. Suppose we say that after t second it will touch the ground. So the first part is when it will touch the ground. After t second it will touch the ground. So here two concept we have to understand about vector. As the ball first of all moving at upwards direction, then if I take that as plus, then this will be our minus. This will be our minus. So we can write as the height of the tower is 40 meter. The height of the tower is 40 meter. So as I take the upper direction of the point O is positive, then this side will be negative. So our displacement or distance of 40 meter will be negative according to the vector theory. So it will be our 40 meter. If I take this, not 40 meter. So our equation is for h equals to vy naught t minus of half of gt square. So here we'll put hs minus minus h. So if I put the value of h, the h is 40, and the value of vy naught t is the value of vy naught is 10. The t I have to find out, minus half of the value of g is 10 t square. Then the whole formula will be like 5 t square plus 10t minus 40 equals to 0, or you can write this thing as not minus 40 is plus 40 equals to 0, or you can write this thing as 5t square plus minus 10t minus 40 equals to 0, or t square minus 2t minus 8 equals to 0. So if I use the formula of quadratic equation, the t will be t equals to plus minus no plus minus t will be minus of minus 2 plus minus root over minus 2 whole square minus 4 into 1 into 8 divided by no 8 will no not 8 minus 8 into minus 8 divided by 2 into 1. So we only take the value of positive t, then the value of positive t will be 4 seconds. The value of the positive t will be 4 seconds. So we find out that after 4 seconds it will touch the ground. It will touch the ground. So now the second part is, what distance from the bottom of the tower will the ball touch the ground? We know, as we take this as x meter, we know along x axis x equals to, then it is the second part, x equals to vx naught into t from the equation we derived. So for vx naught into t, we can write as the value of vx naught equals to 17.32, and the value of t, we find out that it will take 4 seconds to reach the ground. So value of t is 4 seconds, which will be equals to 69.28 meters. 69.28 meter. So we solve the first part, when and what distance from the bottom of the tower will the ball touch the ground. Now the second part is, also calculate the velocity of the ball when it touches the ground. So we have to find out what is the velocity when it touches the ground. So for the second part, when it strikes the ground, with which velocity it will strike the ground. So first of all, you have to find out the component along x-axis of this v. So that is vx, and we know the formula of vx equals to v naught cos theta naught, and which is equals to 17.32 meter per second. And along y-axis, now here we find out that when it touches the ground, the velocity of along y-axis is the negative half of this o. So now our v1 naught will be minus, and we know the formula is minus half of, not half of gt, is plus it is plus half of plus gt, as when it comes down the g is positive at that side. So if I find out this for equation, v1, the value of v1 naught equals to 10, and we know the value of g equals to 10, and that t equals to 4 seconds. We find out that along y-axis the velocity will be 30 meter per second. So for the velocity when it touches the ground, equals to v equals to over vx square plus vy square, which is equals to 34.64 meter per second. So we solve two problems about projectile motion. Here we saw some concept about projectile motion, and we also discussed horizontal projectile motions. That's all for today's video. In our next lecture, we'll discuss about circular motion, which is also a two-dimensional motion. Like this video and subscribe to our channel. Thank you.